In a future not too far away, humanity's survival in the vast expanse of space could hinge on a fleet of unsung heroes, robotic space rescue drones, armed with artificial intelligence that rivals human ingenuity. Picture this: a stranded astronaut drifting helplessly, a spacecraft crippled by a malfunction, or a rogue asteroid on a collision course with Earth. In these moments of cosmic crisis, it won't be a human in a suit rushing to the rescue. It will be a machine designed to navigate the unforgiving void and make split-second decisions that could mean the difference between life and disaster. Today, we're diving into the groundbreaking world of robotic space rescue drones and AI, uncovering how these technologies are transforming our ability to respond to emergencies in space. From their cutting-edge designs to their life-saving capabilities, we'll explore how they're redefining the future of space exploration and emergency response. This isn't just science fiction, it's the next chapter in humanity's journey to the stars. When humanity first ventured beyond Earth's atmosphere, the concept of space rescue was almost non-existent. Early missions relied on rudimentary systems, manual parachutes, basic recovery protocols, and a lot of crossed fingers. Back then, the idea of rescuing an astronaut or repairing a spacecraft in orbit seemed like a distant dream. But as space exploration advanced, so did the need for more sophisticated solutions. The Apollo era brought some of the first semi-autonomous recovery systems, but even those were limited, requiring significant human intervention and ground-based control. Fast forward to today, and the landscape of space rescue has transformed dramatically. Robotic space rescue drones stand at the forefront of this evolution, blending robotics, artificial intelligence, and cutting-edge space engineering into one seamless system. These drones aren't just tools, they're game changers, designed to operate in environments where humans simply can't, whether it's the crushing vacuum of space, the intense radiation of cosmic storms, or the chaotic terrain of an asteroid field. They're built to tackle challenges that were once considered insurmountable. Imagine a spacecraft crippled by a micrometeoroid impact, its systems failing rapidly. In the past, such a scenario might have spelled disaster, but with robotic rescue drones, the story changes. Equipped with advanced AI, these machines can assess the damage, navigate through debris, and perform repairs with precision, all without risking human lives. The journey to this point hasn't been easy. It's taken decades of innovation, from early experiments with remote-controlled probes to the development of fully autonomous systems that can think, adapt, and act in real time. Each step forward has been driven by the growing complexity of space missions and the realization that humans alone can't handle every emergency. As missions push deeper into the cosmos to Mars, the outer planets, and beyond, the demand for reliable, intelligent rescue technology will only grow. Robotic space rescue drones aren't just a luxury, they're becoming a necessity, a critical part of humanity's toolkit as we reach for the stars. What's truly fascinating is how these drones reflect the convergence of multiple disciplines. Robotics gives them the physical capability to move and manipulate objects in zero gravity. Artificial intelligence allows them to make split-second decisions in high-pressure scenarios. And space engineering ensures they can withstand the brutal conditions of the cosmos. Together, these elements create a system that's not only capable of saving lives, but also redefining what's possible in space exploration. As we look back at the history of space rescue, it's clear that these drones aren't just the next step, they're the future. At the core of every robotic space rescue drone lies a symphony of cutting-edge technology, where hardware and software work in perfect harmony to tackle the challenges of space. Imagine a machine that's part engineer, part navigator, and part problem solver, all rolled into one. These drones are powered by advanced propulsion systems, allowing them to maneuver effortlessly in the zero-gravity environment of space. Whether it's adjusting their trajectory to avoid debris or making a rapid approach to a damaged spacecraft, their propulsion systems are finely tuned for precision and agility. But propulsion is just the beginning. These drones are also equipped with high-resolution sensors that act as their eyes and ears in the void. Cameras, LiDAR, and infrared scanners work together to create a detailed map of their surroundings, enabling them to detect hazards, assess damage, and locate targets with incredible accuracy. Think of it like a surgeon's toolkit, but instead of a hospital operating room, the operating theater is the vast, unpredictable expanse of space. What truly sets these drones apart, though, is their artificial intelligence. In environments where communication delays can make real-time human control impossible, AI steps in to fill the gap. These drones are designed to analyze data, identify problems, and execute solutions, all in a matter of seconds. For example, if a spacecraft's solar panel is damaged, the drone's AI can assess the severity of the issue, select the right tools from its modular kit, and carry out the repair with surgical precision. It's like having a highly skilled technician on standby, ready to act at a moment's notice. The modular design of these drones is another game changer. They're not limited to a single task. Instead, they can be outfitted with a variety of tools depending on the mission. Need to weld a cracked hull? There's a tool for that. Have to retrieve a stranded satellite? No problem. This adaptability makes them invaluable in emergencies, where the nature of the crisis can change in an instant. Of course, none of this would be possible without the robust engineering that allows these drones to survive the harsh conditions of space. From extreme temperatures to intense radiation, every component is built to endure the unforgiving environment. It's a testament to human ingenuity, a machine that can thrive where even the hardiest humans would struggle. When you step back and look at the bigger picture, it's clear that robotic space rescue drones are more than just tools. They're a bridge between humanity's ambitions and the realities of space exploration. By combining advanced hardware, intelligent software, and modular versatility, they're redefining what's possible in emergency response and paving the way for safer, more ambitious missions to come. At the heart of every robotic space rescue drone lies a powerful force, artificial intelligence. It's the invisible yet indispensable brain that turns these machines into more than just tools. They become problem solvers, decision makers, and even collaborators. In the unpredictable environment of space, where every second counts and human intervention can be delayed by communication lags, AI steps in to fill the gap. It's what allows these drones to analyze vast amounts of data, adapt to sudden changes, and execute complex tasks with a level of precision that would be impossible for remote operators. One of the most remarkable aspects of AI in space rescue is its ability to learn and improve over time. Through machine learning algorithms, these systems don't just follow pre-programmed instructions, they evolve. Every mission, every challenge, and every success becomes a lesson. Imagine a drone that encounters a new type of debris during a rescue operation. Using AI, it can analyze the situation, adjust its approach, and store that experience in its memory. The next time it faces a similar obstacle, it's better prepared, faster, and more efficient. This continuous cycle of learning is what makes AI-driven drones not just reactive, but proactive, constantly refining their capabilities to meet the demands of space emergencies. Real-time problem solving is another area where AI shines. Space is a dynamic environment, filled with unexpected hazards like micrometeoroids, radiation bursts, or sudden equipment failures. In these moments, a drone's AI can assess the situation in milliseconds, rerouting its path to avoid debris or diagnosing a malfunctioning spacecraft's issue. It's like having a highly skilled technician on board, one that never panics, never hesitates, and always knows the right move. For example, if a spacecraft's life support system begins to fail, the drone's AI can quickly identify the problem, prioritize the repair, and execute the fix, all while the crew remains safe and the mission stays on track. Perhaps one of the most exciting advancements is the ability of AI-driven drones to collaborate. Picture a fleet of these machines working together, each communicating with the others to tackle a complex rescue operation. One drone might focus on stabilizing a damaged spacecraft, while another retrieves critical supplies or repairs a broken component. Through AI, they can coordinate their efforts, share data, and adapt their strategies in real time. This level of teamwork isn't just impressive, it's revolutionary, transforming how we approach large-scale space emergencies. The integration of AI and robotics is more than just a technical achievement, it's a paradigm shift in space exploration. By combining the physical capabilities of drones with the intellectual prowess of AI, we're creating systems that can think, act, and even innovate in ways that were once the realm of science fiction. These technologies aren't just enhancing our ability to respond to emergencies, they're redefining what's possible, opening up new frontiers for exploration, and ensuring that humanity's journey into the cosmos is safer, smarter, and more resilient than ever before. Space is no place for the unprepared. The cosmos is a relentless adversary, throwing everything from bone-chilling cold to searing heat, deadly radiation, and the disorienting absence of gravity at anything that dares to venture beyond Earth's protective atmosphere. For robotic space rescue drones, surviving these extremes isn't just a goal, it's a necessity. Every component of these machines is a product of meticulous engineering, designed to endure conditions that would cripple most technology. Take their exteriors, for example. To combat the extreme temperature swings from the icy cold of deep space to the scorching heat near a star, these drones are coated with advanced thermal-resistant materials. These coatings act like a high-tech shield, reflecting heat away when it's too hot and insulating against the cold when it's freezing. It's a delicate balance, ensuring the drone's internal systems remain stable no matter what the environment throws at them. Radiation is another formidable challenge. In space, cosmic rays and solar flares can fry sensitive electronics, turning a high-tech drone into a lifeless hunk of metal. To counter this, engineers use radiation-hardened components, specially designed to resist these energetic particles. Think of it as armor for circuits, built to absorb and deflect the kind of radiation that would render ordinary electronics useless. But durability isn't the only concern. These drones also need to be nimble and efficient, especially in zero-gravity conditions. That's why they're constructed to be lightweight yet robust, using materials like advanced composites and alloys that offer strength without bulk. Every gram saved means more maneuverability and longer operational life, crucial factors when every second counts in an emergency. And then there's the challenge of microgravity. Without the pull of Earth's gravity, even simple tasks like moving or gripping objects require careful design. Drones are equipped with specialized thrusters and tools that allow them to navigate and interact with their surroundings effortlessly. Imagine trying to repair a spacecraft while floating weightlessly. It's a task that demands precision engineering, and these drones are built to deliver exactly that. What's truly remarkable is how all these elements come together. From heat-resistant coatings to radiation-hardened electronics, lightweight materials to microgravity-optimized tools, every piece of the puzzle is designed to ensure these drones can not only survive but thrive in the harshest conditions imaginable. It's a testament to human ingenuity, a reminder that even in the face of the cosmos' most extreme challenges, we're capable of creating technology that rises to the occasion. This level of engineering doesn't just make these drones durable, it makes them indispensable. As we push further into the unknown, these machines will be our first responders, our repair crews, and our lifelines in the void. They're not just built for emergencies, they're built to ensure that no matter what happens in space, humanity has a fighting chance. Imagine if the crew of Apollo 13 had more than just their ingenuity and ground control to rely on during their harrowing journey. The mission, often called a successful failure, is a testament to human resilience. But what if robotic space rescue drones had been part of the equation? Let's rewind to that fateful moment when an oxygen tank exploded, crippling the spacecraft and leaving the astronauts in a desperate fight for survival. Now, picture a fleet of advanced drones, equipped with cutting-edge AI and repair tools, ready to step in. The first challenge would have been diagnosing the issue. With no way to visually inspect the damaged service module from inside the spacecraft, the crew and ground control were left piecing together data from limited sensors. A rescue drone, however, could have swiftly maneuvered outside the spacecraft, using its high-resolution cameras and sensors to scan the damage in real time. Within minutes, it could have provided a clear assessment of the oxygen tank rupture, allowing the crew to focus on solutions rather than speculation. Next, consider the critical repairs needed to stabilize the spacecraft. The crew, famously Jury, rigged a carbon dioxide scrubber using duct tape and spare parts, a brilliant but risky improvisation. A robotic drone, armed with modular tools, could have taken on this task with precision. It might have sealed leaks, rerouted systems, or even delivered replacement parts stored in its cargo bay. The drone's AI could have analyzed the spacecraft systems, identifying the most effective repairs and executing them without putting the astronauts at further risk. One of the most dangerous aspects of the Apollo 13 mission was the need to power down the spacecraft to conserve energy, leaving the crew in freezing conditions. A rescue drone could have played a vital role here, too. Equipped with thermal blankets or even portable heaters, it could have provided the crew with some much-needed warmth, reducing the physical toll of their ordeal. But perhaps the most profound impact would have been on the crew's morale. Stranded over 200,000 miles from Earth, with no guarantee of survival, the psychological strain was immense. A robotic companion, capable of offering assistance and reassurance, could have provided not just physical support but emotional comfort. It's a reminder that technology isn't just about solving technical problems, it's about safeguarding the human spirit in the face of adversity. This hypothetical scenario isn't just a thought experiment, it's a glimpse into the transformative potential of robotic space rescue drones. By revisiting Apollo 13 through this lens, we see how these machines could have turned a near disaster into a more manageable crisis. It's a powerful reminder of how far we've come and how much further we can go when we combine human courage with the precision and intelligence of advanced technology. The lessons from Apollo 13 remind us that space exploration is as much about preparation as it is about innovation. With robotic rescue drones, we're not just preparing for the unknown, we're redefining what's possible, ensuring that future missions are safer, smarter, and more resilient than ever before. Navigating the unpredictable void of space is no small feat, especially when every second counts. For robotic space rescue drones, the ability to move autonomously through chaotic environments like asteroid fields or debris clouds is absolutely critical. Unlike Earth, where GPS and detailed maps guide our way, space offers no such luxuries. Out there, it's a relentless, ever-changing landscape where obstacles can appear without warning, and the margin for error is razor thin. That's where advanced navigation systems come in, transforming these drones from mere machines into precision pilots of the cosmos. At the heart of these systems lies a suite of cutting-edge sensors and cameras, working in harmony to create a real-time map of the drone's surroundings. High-resolution cameras capture visual data, while LiDAR, a technology that uses laser pulses to measure distance, builds a three-dimensional model of the environment. Infrared sensors detect heat signatures, helping the drone identify objects even in the pitch darkness of space. It's like giving the drone a set of superhuman senses, allowing it to see in ways we can't. But raw data alone isn't enough. That's where artificial intelligence steps in, acting as the drone's brain. Using complex algorithms, the AI processes the incoming data, identifying potential hazards and calculating the safest path forward. Imagine trying to navigate a dense asteroid field. The drone's AI doesn't just avoid collisions, it predicts the trajectory of each asteroid, adjusting its course in milliseconds to ensure a smooth journey. It's a level of precision and speed that human operators, even with the best training, simply couldn't match. What makes this even more impressive is the drone's ability to adapt on the fly. Space is anything but static. Debris clouds shift, asteroids drift, and sudden solar flares can disrupt communication. In these situations, the drone's AI doesn't just follow a pre-programmed route. It analyzes the situation in real time, recalculating its path as conditions change. This adaptability is what turns a good navigation system into a life-saving one, ensuring the drone can handle whatever the cosmos throws its way. And it's not just about avoiding obstacles. These navigation systems also play a crucial role in mission success, whether it's locating a stranded spacecraft, docking with a damaged satellite, or delivering critical supplies. The drone's ability to navigate with pinpoint accuracy is what makes these tasks possible. Think of it as a cosmic delivery service, where every package arrives exactly where it needs to be, no matter how treacherous the journey. The implications of this technology go far beyond rescue missions. As we push further into space, autonomous navigation will be key to exploring uncharted territories, from the icy moons of Jupiter to the dusty plains of Mars. These drones are paving the way for a future where humanity can venture deeper into the cosmos, confident that we have the tools to navigate its challenges. In the end, it's not just about avoiding asteroids or dodging debris. It's about creating a system that can think, adapt, and act in the most extreme conditions imaginable. Autonomous navigation isn't just a feature of robotic space rescue drones. It's the foundation of their success, ensuring that when disaster strikes in the void, these machines are ready to rise to the occasion. When it comes to tackling the most complex challenges in space, sometimes one drone isn't enough. That's where the concept of swarm intelligence comes into play, a revolutionary approach where multiple drones work together as a single, highly coordinated team. Picture a flock of birds moving in perfect unison, or a school of fish darting through the water in synchronized harmony. Now imagine that same level of teamwork, but with advanced robotic drones navigating the unforgiving void of space. This isn't just about having more hands on deck. It's about creating a system where each drone contributes its unique strengths, sharing data and adapting in real time to achieve a common goal. At the heart of swarm intelligence lies a decentralized approach. Unlike traditional systems where a single controller directs every action, these drones operate as a collective. Each unit is equipped with its own sensors, processors, and decision-making capabilities, allowing it to act independently while still communicating with the group. This setup creates a dynamic network where information flows seamlessly, enabling the drones to divide tasks, cover more ground, and respond to unexpected changes with incredible speed. Take, for example, a scenario where a spacecraft has suffered extensive damage. A single drone might struggle to assess the full scope of the problem, let alone carry out the necessary repairs. But with a swarm of drones, the situation changes dramatically. One drone could focus on scanning the damaged area, creating a detailed map of the issue. Another might begin sealing leaks or stabilizing the structure, while yet another retrieves spare parts or tools. All the while, they're sharing data in real time, ensuring that every action is coordinated and efficient. What makes swarm intelligence truly remarkable is its adaptability. In space, conditions can shift in an instant, debris clouds can scatter, systems can fail, or new hazards can emerge. A swarm of drones, connected through AI, can quickly reassess the situation and redistribute tasks as needed. If one drone encounters an obstacle, the others can adjust their paths or take over its responsibilities without missing a beat. It's a level of flexibility and resilience that's simply unattainable with a single drone or a human-controlled team, but the potential of swarm intelligence goes beyond rescue missions. Imagine using this technology to map the surface of an asteroid. A single drone might take days or even weeks to complete the task, but a swarm could cover the entire area in a fraction of the time, gathering data from multiple angles simultaneously. Or consider the exploration of distant moons or planets, where swarms of drones could work together to collect samples, analyze terrain, and search for signs of life, all while navigating treacherous environments with ease. The science behind swarm intelligence is as fascinating as its applications. Inspired by nature, where animals like ants, bees, and birds demonstrate incredible collective behavior, researchers have developed algorithms that mimic these patterns. These algorithms allow drones to make decisions based on simple rules, such as maintaining a certain distance from their neighbors or aligning their movements with the group. Over time, these interactions create a kind of emergent intelligence where the whole becomes far greater than the sum of its parts. As we look to the future, the possibilities for swarm intelligence in space are virtually limitless. From repairing spacecraft to exploring uncharted worlds, this collaborative approach is poised to revolutionize how we tackle the challenges of the cosmos. It's a reminder that even in the vastness of space, teamwork, whether among humans or machines, remains one of our greatest assets. By harnessing the power of swarm intelligence, we're not just solving problems, we're redefining what's possible in the final frontier. In the vast, unpredictable expanse of space, hesitation can mean the difference between life and catastrophe. When emergencies strike, whether it's a stranded astronaut, a malfunctioning spacecraft, or an incoming asteroid, there's no room for second guessing. That's where the real-time decision-making capabilities of robotic space rescue drones come into play. These machines aren't just tools, they're problem solvers, equipped with artificial intelligence that allows them to analyze, assess, and act in the blink of an eye. Imagine a scenario where a spacecraft's life support system begins to fail. The crew is running out of oxygen, and every passing second brings them closer to disaster. A rescue drone, deployed to assist, doesn't have the luxury of waiting for instructions from Earth. Communication delays could take minutes, or even hours, depending on the distance. Instead, the drone's AI steps in, instantly evaluating the situation. It reviews sensor data, identifies the malfunction, and determines the most effective repair strategy. Within moments, it's executing the fix, rerouting systems, or even delivering replacement parts to stabilize the spacecraft. What makes this level of decision-making possible is the AI's ability to process vast amounts of data at lightning speed. In high-stakes scenarios, every piece of information matters. Temperature readings, oxygen levels, structural integrity, and even the position of nearby debris. The drone's AI synthesizes all of this, weighing the risks and benefits of each potential action. It's not just about choosing the right solution, it's about choosing the best one, even when time is running out. Take asteroid deflection as another example. If a rogue asteroid is detected on a collision course with Earth, there's no margin for error. A robotic drone tasked with altering its trajectory must calculate the optimal point of impact, the necessary force, and the safest approach, all while navigating through a field of debris. The AI doesn't just rely on pre-programmed instructions, it adapts to the asteroid's movement, recalculating its strategy in real time to ensure success. This isn't just about brute force, it's about precision, timing, and intelligent decision-making under extreme pressure. Of course, these decisions aren't made in isolation. The AI is constantly learning, drawing on past experiences and simulations to refine its strategies. Every mission, every challenge adds to its knowledge base, making it more capable of handling future emergencies. It's a system that grows smarter with every task, ensuring that it's always ready for the next high-stakes scenario. What's truly remarkable is how these drones balance speed with accuracy. In space, where the consequences of a wrong move can be catastrophic, there's no room for guesswork. Yet, these machines manage to act decisively without sacrificing precision. They're not just responding to emergencies, they're anticipating them, using predictive algorithms to stay one step ahead. It's a level of foresight and adaptability that makes them indispensable in the cosmos. This ability to think and act in real time isn't just a technical marvel, it's a testament to the power of collaboration between humans and machines. By combining the ingenuity of human engineers with the precision of artificial intelligence, we've created systems that can handle the unimaginable. These drones aren't just tools for emergencies, they're partners in exploration, ensuring that humanity's journey into the stars is safer, smarter, and more resilient than ever before. As we continue to push the boundaries of space exploration, the role of real-time decision-making will only grow more critical. Whether it's rescuing astronauts, repairing spacecraft, or protecting Earth from celestial threats, these drones are proving that when it comes to high-stakes scenarios, they're more than up to the task. They're not just responding to the challenges of space, they're redefining what's possible, one split-second decision at a time. Even with the most advanced artificial intelligence, robotic space rescue drones don't operate in isolation. They're part of a larger ecosystem, one that includes astronauts, mission controllers, and ground teams working together to achieve a common goal. While these drones are designed to handle tasks autonomously, human oversight remains a critical component of their success. This partnership between humans and machines isn't just about control, it's about collaboration, leveraging the strengths of both to tackle the challenges of space emergencies. At the heart of this collaboration are intuitive interfaces that allow humans and drones to communicate seamlessly. Think of it as a high-tech conversation, where every command, gesture, or piece of data is exchanged effortlessly. For astronauts, this might mean using a tablet-like device to guide a drone through a repair task, with real-time feedback displayed on the screen. For mission controllers on Earth, it could involve sophisticated software that visualizes the drone's actions and surroundings, allowing them to provide guidance or intervene when necessary. These interfaces are more than just tools, they're bridges, connecting human expertise with robotic precision. One of the most exciting developments in human-drone interaction is the use of voice commands. Imagine an astronaut floating in zero gravity, directing a drone to retrieve a tool or inspect a damaged section of the spacecraft, all through simple spoken instructions. This hands-free approach not only saves time, but also reduces the cognitive load on astronauts, allowing them to focus on higher priority tasks. Advanced natural language processing ensures the drone understands the nuances of human speech, whether it's a direct command or a more complex request. It's a level of interaction that feels almost conversational, blurring the line between human and machine. But communication isn't just one way. These drones are equipped to provide real-time updates, alerting astronauts and mission controllers to potential hazards or completed tasks. For example, if a drone detects a leak in a spacecraft's hull, it can immediately notify the crew, highlighting the issue on their interface and suggesting possible solutions. This two-way flow of information creates a dynamic partnership where humans and drones work together to make informed decisions. Of course, there are times when human intervention is essential. While AI can handle many tasks autonomously, certain situations require the judgment and creativity that only humans can provide. In these cases, mission controllers can take control of the drone remotely, using its sensors and tools to carry out precise maneuvers. This hybrid approach, combining autonomous operation with human oversight, ensures that the drone can adapt to any situation, no matter how unexpected. What's truly remarkable about this relationship is how it evolves over time. As astronauts and mission controllers work with these drones, they learn to anticipate each other's strengths and limitations. The drones, in turn, refine their algorithms based on human feedback, becoming more intuitive and effective with each mission. It's a continuous cycle of improvement where both humans and machines grow together, pushing the boundaries of what's possible in space rescue. This synergy between humans and drones isn't just about technology, it's about trust. Astronauts need to know that these machines will perform reliably in high-stakes scenarios, while drones rely on human guidance to navigate the complexities of space. Together, they form a team that's greater than the sum of its parts, capable of overcoming challenges that would be insurmountable for either alone. As we look to the future, the relationship between humans and drones will only deepen. From exploring distant planets to establishing permanent settlements in space, these partnerships will be at the forefront of our efforts to conquer the cosmos. By bridging the gap between human ingenuity and robotic precision, we're not just improving emergency response, we're redefining what it means to explore, innovate, and thrive in the final frontier. Training an AI to handle the unpredictable chaos of space emergencies is no small task. It's like preparing for a marathon where the finish line keeps moving. Before a robotic space rescue drone can even be deployed, its artificial intelligence must undergo an intense and meticulous training process designed to equip it with the skills to tackle everything from minor malfunctions to full-blown cosmic crises. This isn't just about programming, it's about teaching a machine to think, adapt, and act in ways that mimic human ingenuity, but with the speed and precision only AI can deliver. The foundation of this training lies in simulation, an endless virtual playground where the AI is exposed to every conceivable emergency scenario. Picture this: a spacecraft's oxygen system fails, an asteroid hurtles toward Earth, or a satellite loses power in the middle of a critical mission. In these simulations, the AI must navigate the problem, assess the risks, and execute a solution, all while learning from its successes and failures. It's a process that requires millions of iterations, each one refining the AI's decision-making abilities and preparing it for the unexpected. But simulations alone aren't enough. The real magic happens when machine learning algorithms step in to analyze the data. These algorithms sift through the outcomes of countless scenarios, identifying patterns and extracting insights that help the AI develop strategies for success. For example, if a simulation reveals that a certain repair technique works best under specific conditions, the AI files that knowledge away, ready to apply it in a real-world emergency. Over time, this cycle of trial, error, and learning transforms the AI from a blank slate into a highly capable problem solver. One of the biggest challenges in this process is ensuring the AI can handle the sheer diversity of space emergencies. Space is a place of extremes where no two crises are alike. A drone might need to repair a cracked hull one moment and deflect an asteroid the next. To prepare for this, engineers create simulations that push the AI to its limits, testing its ability to switch gears and adapt to new challenges. It's a bit like training a firefighter to handle everything from a kitchen fire to a forest blaze. Each scenario requires a different approach, and the AI must be ready for anything. Another critical aspect of AI training is teaching the system to prioritize. In a high-stakes emergency, time is the most valuable resource, and the AI must know which tasks to tackle first. For instance, if a spacecraft's life support system is failing while its propulsion system is also damaged, the AI has to decide which issue poses the greater immediate threat. This ability to triage, to make split-second decisions about what matters most, is what separates a good AI from a truly exceptional one. Of course, the training process isn't just about teaching the AI what to do, it's also about teaching it what not to do. Engineers deliberately introduce scenarios where the AI might make mistakes, allowing it to learn from those errors and avoid repeating them in the future. This iterative approach ensures that when the AI faces a real emergency, it's not just relying on a set of pre-programmed instructions, it's drawing on a deep well of experience, honed through countless simulations. What's truly remarkable is how this training process reflects the complexity of space itself. Just as space is vast, unpredictable, and full of surprises, so too is the journey of training an AI. It's a process that requires patience, creativity, and an unwavering commitment to excellence. But the payoff is immense, an AI that's not just capable of handling space emergencies, but excelling in them. As we look to the future, the training of AI for space rescue will only become more sophisticated. Advances in machine learning, combined with increasingly realistic simulations, are opening up new possibilities for how we prepare these systems. It's a reminder that even in the realm of artificial intelligence, the key to success lies in preparation, adaptation, and a relentless drive to push the boundaries of what's possible. By investing in the training of AI, we're not just building better machines, we're creating partners that can stand alongside humanity as we venture deeper into the cosmos. These drones, shaped by countless hours of virtual experience, are poised to become our allies in the most challenging environments imaginable, ready to rise to the occasion whenever and wherever they're needed. As we push the boundaries of space exploration with AI-driven rescue drones, we're also stepping into uncharted ethical territory. These machines, capable of making split-second decisions in life or death situations, raise profound questions about responsibility, accountability, and the value of human life. Who holds the reins when a drone operates autonomously? Who bears the burden if something goes wrong? These aren't just hypothetical questions. They're critical considerations that shape how we design, deploy, and trust these systems. At the core of this debate is the concept of accountability. When a human pilot makes a mistake, there's a clear chain of responsibility. But with AI-driven drones, the lines blur. Is it the engineer who programmed the system, the mission controller who authorized its deployment, or the AI itself, which made the decision in the moment? These questions don't have easy answers, but they're essential to address as we integrate AI deeper into space operations. Another pressing concern is how these systems prioritize human life. In emergencies, every decision carries weight, whether it's choosing to save a stranded astronaut or divert resources to protect a spacecraft. AI must be programmed to make these choices ethically, balancing the immediate needs of individuals with the broader goals of the mission. This requires not just technical expertise, but a deep understanding of human values, ensuring that the AI's decisions align with the principles we hold dear. Transparency is also key. For these systems to earn our trust, we need to know how they work. What data are they using to make decisions? How do they weigh competing priorities? By designing AI that can explain its reasoning, known as explainable AI, we can create systems that are not only effective but also understandable. This transparency fosters trust, allowing humans to feel confident in the AI's actions, even in high-stakes scenarios. But the ethical challenges don't end there. As AI becomes more autonomous, we must also grapple with the potential for unintended consequences. What happens if a drone misinterprets a command or misjudges a situation? How do we ensure that these systems don't inadvertently cause harm, even with the best intentions? These risks highlight the importance of rigorous testing, continuous oversight, and fail-safes that can intervene if the AI veers off course. Ultimately, the goal is to strike a balance between autonomy and accountability, efficiency and ethics, innovation and responsibility. By addressing these ethical dilemmas head-on, we can create technologies that not only save lives but also reflect our shared values. It's a reminder that, as we reach for the stars, we must also ground ourselves in the principles that define us. This isn't just about building better machines, it's about building a better future, one where technology serves humanity, even in the most extreme environments. By weaving ethics into the fabric of AI-driven space rescue, we ensure that these systems aren't just tools for exploration, but partners in our journey, guided by the same moral compass that has always driven us forward. Robotic space rescue drones are more than just first responders. They're versatile pioneers with the potential to redefine how we explore and utilize the cosmos. While their primary mission is to save lives and repair spacecraft, their capabilities open doors to a future where these machines become indispensable tools for planetary exploration, resource extraction, and even the construction of habitats beyond Earth. By repurposing their advanced technology, we can transform these drones from emergency responders into architects of humanity's interstellar ambitions. One of the most exciting possibilities lies in planetary exploration. Imagine sending a fleet of drones to Mars, equipped with high-resolution sensors and AI-driven navigation systems. These machines could traverse the planet's rugged terrain, mapping its surface, analyzing soil samples, and searching for signs of ancient life, all without risking human lives. Unlike traditional rovers, which are limited by their size and mobility, drones could fly over obstacles, explore caves, and access areas that are otherwise unreachable. They'd act as scouts, gathering data and paving the way for future human missions. It's a vision that transforms these drones from rescue tools into essential explorers, expanding our understanding of the solar system. But exploration is just the beginning. These drones could also play a pivotal role in asteroid mining, a concept that sounds like science fiction, but is rapidly becoming a reality. Asteroids are treasure troves of precious metals and rare minerals, resources that could fuel future space missions and even support life on Earth. Robotic drones, with their ability to navigate zero-gravity environments and manipulate objects, could be deployed to mine these celestial bodies. Equipped with drills, robotic arms, and advanced AI, they could extract materials, process them on site, and transport them back to Earth or to other space habitats. It's a bold vision of space as not just a frontier for exploration, but a source of untapped wealth. And then there's the potential for construction. As humanity looks to establish permanent settlements on the Moon, Mars, or even floating habitats in space, the need for reliable construction tools becomes clear. Robotic drones could take on this challenge, using their modular designs and precision engineering to assemble habitats, repair infrastructure, and even 3D print structures using local materials. Picture a drone swarm building a lunar base, each unit contributing its unique skills to create a safe, functional environment for astronauts. It's a future where these machines aren't just repairing damage, they're building the foundations of humanity's extraterrestrial future. What makes these applications so compelling is how seamlessly they build on the drone's existing capabilities. The same AI that guides a rescue drone through a damaged spacecraft could navigate the treacherous terrain of an asteroid. The sensors that detect leaks in a space station could analyze the composition of Martian soil. These aren't entirely new technologies, they're adaptations of what we've already created, repurposed to meet the challenges of tomorrow. This adaptability is a testament to the ingenuity behind these systems. By designing drones that are not only capable of handling emergencies, but also flexible enough to tackle a wide range of tasks, we're creating tools that can grow with our ambitions. They're not just solving problems, they're enabling opportunities, opening up new frontiers for exploration, resource utilization, and human settlement. As we look to the future, it's clear that robotic space rescue drones are more than just a single-purpose technology. They're a platform for innovation, a foundation upon which we can build the next chapter of space exploration. Whether they are mapping distant planets, mining asteroids, or constructing habitats, these machines are poised to play a central role in humanity's journey to the stars. It's a future that's not just about surviving in space, it's about thriving, building, and growing in ways we've only begun to imagine. By reimagining the potential of these drones, we're not just preparing for emergencies, we're shaping a future where space becomes a place of opportunity, discovery, and endless possibility. The next era of space exploration won't just be defined by human courage, it will be powered by the ingenuity of machines, working alongside us to unlock the cosmos. Even as robotic space rescue drones push the boundaries of what's possible in space, they're not without their limitations. While these machines are marvels of engineering, they operate in an environment that's relentless and unforgiving, where even the smallest oversight can lead to catastrophic failure. One of the most pressing challenges is power. Space is a place of extremes, and energy is a precious commodity. Solar panels, the primary source of power for many drones, can only generate so much energy, especially in the shadowy regions of space or during long missions far from the sun. Batteries, while essential for storing power, add weight and complexity, limiting the drone's range and maneuverability. It's a delicate balance, too much reliance on batteries, and the drone becomes sluggish, too little, and it risks running out of power mid-mission. Communication delays pose another significant hurdle. In space, distance isn't just measured in miles, it's measured in time. A signal sent from Earth to a drone orbiting Mars can take anywhere from 4 to 24 minutes to arrive, depending on the planet's positions. That lag makes real-time control impossible, forcing these systems to rely heavily on their AI for decision-making. While AI has come a long way, it's not infallible. There's always the risk of a misjudgment or a missed signal, especially in high-stakes scenarios where every second counts. Then there's the issue of durability. Space is a brutal environment, filled with hazards like micrometeoroids, radiation, and extreme temperature swings. Even the most advanced materials can degrade over time, leaving drones vulnerable to wear and tear. A single impact from a tiny piece of debris could disable a critical sensor or damage a propulsion system, rendering the drone useless. Engineers are constantly working to create more resilient designs, but the challenge lies in balancing strength with weight. Too much armor, and the drone becomes too heavy to move efficiently. Too little, and it risks catastrophic failure. Another limitation lies in the complexity of the tasks these drones are asked to perform. While AI has made incredible strides, it still struggles with tasks that require creativity or intuition qualities that come naturally to humans. For example, repairing a spacecraft's hull might involve improvisation, using unconventional tools or techniques to address an unforeseen issue. A drone, no matter how advanced, might lack the flexibility to think outside the box in the same way a human could. Despite these challenges, the potential for innovation is immense. Researchers are already exploring solutions, from more efficient energy sources like nuclear batteries to advanced communication systems that reduce delays. New materials like self-healing polymers could help drones withstand the harsh conditions of space, while improvements in AI could enhance their problem-solving capabilities. The key is to view these limitations not as roadblocks, but as challenges that, when overcome, will unlock even greater potential for these systems. Understanding these challenges is crucial because it highlights the gap between where we are and where we need to be. It's a reminder that innovation doesn't happen overnight. It's a process of trial, error, and relentless improvement. By addressing these limitations head-on, we're not just building better drones, we're paving the way for a future where space emergencies are met with confidence and precision. The journey to perfecting these systems is far from over, but every challenge we tackle brings us closer to that goal. It's a testament to human ingenuity and determination, a reminder that even in the face of the cosmos' most daunting obstacles, we're capable of rising to the occasion. And as we continue to push the boundaries of technology, we're not just solving problems, we're shaping the future of space exploration, one innovation at a time. The future of robotic space rescue drones is brimming with potential, fueled by a constant stream of groundbreaking innovations. As technology advances at an unprecedented pace, these systems are poised to become even more capable, resilient, and intelligent. One of the most exciting developments on the horizon is the use of self-healing materials. Imagine a drone that can repair its own hull after a micrometeoroid strike, or a solar panel that patches itself when damaged. These materials, often inspired by biological processes, could drastically extend the lifespan of space drones, reducing the need for repairs and ensuring they remain operational in the harshest conditions. Another game-changing innovation is the integration of quantum computing. While traditional computers rely on binary code, quantum computers use qubits, which can process information at speeds that seem almost magical. For space rescue drones, this could mean lightning-fast calculations, enabling them to navigate complex debris fields, predict asteroid trajectories, or optimize repair strategies in real time. It's a leap forward that could revolutionize how these systems operate, making them not just faster, but also smarter. Advancements in propulsion, technology are also reshaping the possibilities for space rescue. New methods like ion drives and solar sails offer more efficient ways to travel through space, allowing drones to cover greater distances with less fuel. These systems could enable missions to the outer reaches of the solar system, where traditional propulsion methods would fall short. Picture a drone equipped with a solar sail, gliding effortlessly through the cosmos, powered by nothing more than the light of the sun. It's a vision that blends elegance with efficiency, opening up new frontiers for exploration and rescue. Artificial intelligence is another area where rapid progress is being made. Machine learning algorithms are becoming increasingly sophisticated, enabling drones to learn from their experiences and adapt to new challenges. For instance, an AI-trained drone could recognize patterns in spacecraft malfunctions, predicting failures before they happen and taking preemptive action. This predictive capability could transform how we approach space emergencies, shifting from reactive responses to proactive solutions. But it's not just about the drones themselves. It's also about the networks they operate within. Innovations in swarm intelligence are making it possible for multiple drones to work together seamlessly, sharing data and coordinating tasks with unprecedented efficiency. This collaborative approach could be a game changer for large-scale missions, such as repairing a space station or deflecting an asteroid. By working as a unified team, these drones could tackle challenges that would be insurmountable for a single machine. Energy efficiency is another key area of innovation. New power sources, such as compact nuclear reactors or advanced solar cells, could provide drones with the energy they need to operate for longer periods without recharging. This would be particularly valuable for missions in deep space, where sunlight is scarce and traditional power sources are limited. With these advancements, drones could become true long-distance explorers, capable of venturing far beyond our solar system. The possibilities don't stop there. Researchers are also exploring the use of drones for environmental monitoring, using their sensors to track space weather, detect radiation bursts, or even search for signs of extraterrestrial life. These applications highlight the versatility of these systems, showing that their potential extends far beyond emergency response. What's truly exciting is how these innovations are converging, creating a synergy that amplifies their impact. A drone equipped with self-healing materials, quantum computing, and advanced AI isn't just a tool, it's a partner capable of handling challenges we can't yet imagine. By staying at the forefront of technology, we're not just preparing for the future, we're shaping it, ensuring that these systems are ready to meet whatever challenges the cosmos throws our way. As we look ahead, it's clear that the field of robotic space rescue is on the cusp of a new era. With each breakthrough, we're inching closer to a future where space emergencies are met with confidence, precision, and ingenuity. These innovations aren't just enhancing the capabilities of drones, they're redefining what's possible, paving the way for a new chapter in humanity's exploration of the stars. Space emergencies don't recognize borders, they're a universal challenge that demands a united response. Whether it's a stranded astronaut, a malfunctioning satellite, or an incoming asteroid, the stakes are too high for any one nation or organization to handle alone. That's why global collaboration has become a cornerstone of space rescue efforts, bringing together the best minds, resources, and technologies from around the world to tackle these cosmic crises. At the heart of this collaboration is the recognition that space is a shared frontier. No single country has a monopoly on innovation or expertise, and by pooling our collective knowledge, we can achieve far more than we could in isolation. Take, for example, the International Space Station, a shining example of what humanity can accomplish when we work together. This spirit of cooperation is now extending to space rescue, with nations and organizations collaborating on everything from research and development to the deployment of robotic drones. One of the most significant benefits of this global approach is the diversity of perspectives it brings. Engineers in Japan might develop cutting-edge propulsion systems, while scientists in Europe pioneer advanced AI algorithms. Meanwhile, space agencies in the United States and Russia could contribute their expertise in mission control and spacecraft design. By combining these strengths, we create systems that are not only more effective, but also more adaptable to the unpredictable challenges of space. Joint missions are another critical aspect of this collaboration. Imagine a scenario where a satellite owned by one country malfunctions in orbit, threatening to create a debris field that could endanger spacecraft from multiple nations. In such a situation, a multinational team of rescue drones could be deployed, each equipped with tools and expertise provided by different countries. This kind of coordinated effort ensures that no single nation bears the burden alone, while also maximizing the chances of a successful outcome. But collaboration isn't just about sharing technology, it's also about sharing knowledge. International research initiatives are helping to standardize best practices for space rescue, ensuring that every nation has access to the latest advancements. Workshops, conferences, and joint training programs are fostering a global community of experts who can respond to emergencies with a unified approach. It's a reminder that in space, we're all in this together. Of course, global collaboration isn't without its challenges. Differences in priorities, funding, and political climates can sometimes complicate efforts to work together. But the urgency of space emergencies has a way of cutting through these barriers, reminding us of the bigger picture. When lives are at stake and the future of space exploration hangs in the balance, the need for cooperation becomes undeniable. This spirit of unity is already yielding results, from the development of shared protocols for asteroid deflection to the creation of multinational task forces for space debris removal. The world is coming together to address the challenges of space rescue. And as we look to the future, this collaborative approach will only become more important. Missions to Mars, the Moon, and beyond will require a level of coordination and cooperation that transcends borders, ensuring that humanity's journey into the cosmos is not just successful, but also safe. By working together, we're not just solving problems, we're building a foundation for a future where space exploration is a shared endeavor, guided by the principles of cooperation and mutual respect. It's a reminder that even in the vastness of space, we're stronger when we stand united, and as we continue to push the boundaries of what's possible, this spirit of collaboration will be our greatest asset, ensuring that no matter what challenges we face, we're ready to meet them together. Robotic space rescue drones aren't just transforming how we explore the cosmos, they're reshaping how we think about space. As these machines take center stage in missions and media, they're becoming more than just tools. They're symbols of humanity's ingenuity and ambition. From blockbuster movies to educational documentaries, these drones are capturing the public's imagination, offering a glimpse into a future where technology and exploration go hand in hand. But their influence goes deeper than entertainment. It's sparking conversations, inspiring dreams, and even challenging our assumptions about what's possible. In popular culture, these drones often appear as the ultimate problem solvers, swooping in to save the day in the most dramatic of scenarios. Films and TV shows depict them as sleek, intelligent machines, capable of navigating asteroid fields, repairing spacecraft, and even rescuing stranded astronauts. While these portrayals might take creative liberties, they're rooted in real advancements, reflecting the public's fascination with cutting-edge technology. These stories don't just entertain, they inspire. For many, especially young viewers, they plant the seed of curiosity, igniting a passion for science, engineering, and space exploration. But the cultural impact of these drones isn't limited to fiction. Documentaries and news features are bringing their real-world capabilities to life, showcasing how they're revolutionizing emergency response in space. By highlighting their role in missions, whether it's repairing a satellite or aiding astronauts, these stories help demystify the technology, making it relatable and tangible for a broader audience. They remind us that the future isn't some distant dream, it's happening right now, and these drones are at the forefront. This growing visibility is also sparking important conversations about the role of AI and robotics in our lives. As these systems become more autonomous, questions about trust, ethics, and the future of human-machine collaboration are coming to the forefront. How much control should we give to machines in life or death situations? Can we trust them to make decisions that align with our values? These debates aren't just theoretical, they're shaping how we design, deploy, and interact with these technologies, both in space and on Earth. Beyond the debates, these drones are also influencing how we see ourselves in the universe. They remind us that space exploration isn't just about reaching new frontiers, it's about solving problems, pushing boundaries, and working together to overcome challenges. They embody the spirit of innovation, showing that even in the face of the unknown, we have the tools and the creativity to thrive. Perhaps one of the most profound impacts is on the next generation. For aspiring scientists and engineers, these drones are more than just machines, they're a source of inspiration. Schools and educational programs are using them as teaching tools, helping students understand complex concepts like robotics, AI, and space engineering in a hands-on way. By making these technologies accessible and exciting, we're nurturing a new wave of thinkers and creators who will carry the torch of exploration forward. And let's not forget the role of social media and digital platforms in amplifying this cultural shift. Videos of drone missions, simulations, and behind-the-scenes glimpses are going viral, sparking conversations and connecting people across the globe. These platforms aren't just sharing information, they're building a community of enthusiasts, experts, and dreamers who are united by their fascination with space and technology. The cultural impact of robotic space rescue drones is a reminder that technology isn't just about functionality, it's about storytelling. These machines are helping us reimagine what's possible, shaping our collective vision of the future and inspiring us to reach for the stars. Whether through a thrilling movie scene, a thought-provoking documentary, or a classroom demonstration, they're leaving an indelible mark on our culture, proving that the journey into space is as much about innovation as it is about imagination. As these drones continue to evolve, so too will their influence on how we see the cosmos and ourselves. They're not just tools for exploration, they're catalysts for change, pushing us to dream bigger, think deeper, and explore further. And in doing so, they're shaping not just the future of space, but the future of humanity itself. The development and deployment of robotic space rescue drones represent a significant financial commitment, but the long-term economic implications are nothing short of transformative. At first glance, the costs of creating these advanced systems might seem staggering, billions of dollars poured into research, development, and testing. Yet, when we consider the alternative, losing astronauts, spacecraft, or even entire missions, the investment becomes not just justified, but essential. Think of it like insurance. The upfront costs may be high, but the protection they provide is invaluable. One of the most immediate economic benefits lies in the protection of assets. Space missions are incredibly expensive, with costs often running into the hundreds of millions or even billions of dollars. A single failure, whether it's a malfunctioning satellite or a damaged spacecraft, can result in catastrophic financial losses. Robotic rescue drones act as a safeguard, reducing the risk of total mission failure by providing on-the-spot repairs or retrieval. For example, if a satellite's solar panels are damaged, a drone could repair them, extending the satellite's lifespan and saving millions in replacement costs. It's a proactive approach that turns potential disasters into manageable setbacks, but the economic impact doesn't stop there. By investing in space rescue technology, we're also fostering innovation that spills over into other industries. The cutting-edge materials, AI algorithms, and propulsion systems developed for these drones have applications far beyond space. From self-healing materials used in construction to advanced AI systems powering autonomous vehicles on Earth, the ripple effects of this research are immense. These technologies don't just benefit space exploration, they drive economic growth, create jobs, and open up new markets, another key consideration is the sustainability of space exploration. As we venture further into the cosmos, the cost of sending supplies, equipment, and personnel will only increase. Robotic rescue drones can help mitigate these expenses by performing tasks that would otherwise require human intervention. For instance, instead of launching an expensive crewed mission to repair a malfunctioning space station, a drone could handle the job at a fraction of the cost. This efficiency not only saves money, but also reduces the risks to human life, making space exploration more sustainable in the long run. It's also worth noting the potential for international collaboration to offset costs. Space exploration has always been a global endeavor, and pooling resources can make high-tech rescue systems more accessible. Shared missions, joint funding initiatives, and collaborative research can distribute the financial burden while amplifying the benefits. This approach not only makes economic sense, but also strengthens diplomatic ties, fostering a spirit of cooperation that extends beyond the stars. Of course, the economic benefits aren't just about avoiding losses, they're also about creating opportunities. The space industry is rapidly expanding, with private companies and governments alike investing heavily in new ventures. Robotic rescue drones are poised to play a central role in this growth, enabling safer, more ambitious missions that push the boundaries of what's possible. Whether it's mining asteroids for rare minerals or establishing permanent settlements on the moon, these technologies are unlocking new economic frontiers. When we step back and look at the bigger picture, the economic implications of space rescue technology become clear. Yes, the initial investment is substantial, but the returns, both immediate and long-term, are even greater. By protecting assets, driving innovation, and enabling sustainable exploration, these systems are not just a cost, they're an investment in the future. And in a world where space is increasingly seen as the next great frontier, that investment is one we can't afford to ignore. As we continue to push the boundaries of what's possible, the economic case for robotic space rescue drones will only grow stronger. They're not just tools for emergencies, they're enablers of progress, ensuring that humanity's journey into the cosmos is not only bold, but also economically viable. In the end, the true value of these systems lies not just in what they can do, but in what they make possible for generations to come. Space is a realm of endless possibilities and endless uncertainties. From sudden equipment failures to unpredictable cosmic weather, the challenges of space emergencies are as varied as they are unpredictable. Preparing for every conceivable scenario might seem impossible, but that's where simulation steps in, offering a way to train robotic space rescue drones for the unexpected. Think of it as a cosmic rehearsal, where these machines practice for emergencies that may never happen, but could. At the heart of this training is the concept of exposure. By immersing drones in virtual environments that replicate the harsh realities of space, engineers can test their capabilities under extreme conditions. These simulations aren't just about running through a checklist, they're about pushing the limits of what these systems can handle. Picture a drone navigating a debris field, dodging micrometeoroids while simultaneously repairing a damaged spacecraft. Or imagine it grappling with a sudden solar flare, recalibrating its systems in real time to avoid catastrophic failure. These scenarios might sound like scenes from a sci-fi movie, but they're the bread and butter of space rescue training. The beauty of simulation lies in its flexibility. Engineers can create an infinite variety of scenarios, tweaking variables like gravity, temperature, and radiation levels to mimic the unpredictable nature of space. This adaptability allows drones to practice for situations that are rare or even hypothetical, ensuring they're prepared for anything the cosmos might throw their way. It's a bit like training a firefighter to handle everything from a kitchen fire to a forest blaze. Each scenario requires a different approach, and the more diverse the training, the better the readiness. But simulation isn't just about testing hardware, It's also about refining the AI that powers these drones. Through machine learning, the AI analyzes the outcomes of each simulation, identifying patterns and improving its decision-making over time. For example, if a drone struggles to repair a specific type of damage in one simulation, the AI can adjust its strategy for the next attempt. This iterative process creates a feedback loop, where every failure becomes a lesson and every success builds confidence. Over time, the AI evolves into a highly capable problem solver, ready to tackle real-world emergencies with precision and speed. One of the most critical aspects of simulation is its ability to replicate the unexpected. Space is full of surprises, debris clouds that shift, systems that fail without warning, or environmental conditions that change in an instant. By introducing randomness into simulations, engineers can ensure that drones aren't just following a script, they're learning to adapt on the fly. This adaptability is what transforms a good drone into a great one, capable of handling the chaos of space with confidence. Simulation also plays a vital role in mission planning. Before a rescue drone is deployed, mission controllers can use simulations to anticipate potential challenges and develop contingency plans. For example, if a mission involves repairing a spacecraft in a high radiation environment, simulations can help identify the best tools and strategies for the job. This proactive approach not only increases the chances of success, but also reduces the risks to both the drone and any human crew involved. The importance of simulation extends beyond individual missions. As we push further into space, the lessons learned from these virtual environments will shape the design of future drones, making them more resilient, adaptable, and intelligent. It's a continuous cycle of improvement, where each simulation brings us closer to a future where space emergencies are met with precision and confidence. By investing in simulation, we're not just training drones, we're building a foundation for safer, more ambitious space exploration. These virtual environments are more than just training grounds. They're windows into the future, helping us prepare for challenges we can't yet imagine. And as we continue to refine these systems, one thing becomes clear. In the face of the unknown, simulation is our greatest ally, ensuring that when the unexpected strikes, we're ready to rise to the occasion. When we think about rescues, our minds often jump to dramatic scenes on Earth: mountaineers stranded on icy cliffs, survivors pulled from collapsed buildings, or medical teams racing against time in disaster zones. These high-stakes situations have shaped the way we approach emergency response, honing techniques that save lives in the most challenging conditions. But what if these same principles could be applied beyond our planet? As it turns out, many of the strategies used in terrestrial rescues are finding new life in the cosmos, offering valuable lessons for the development of robotic space rescue drones. Take search and rescue operations, for example. On Earth, rescuers rely on a combination of technology and intuition to locate missing individuals, often using drones equipped with thermal imaging and GPS to scour vast areas. In space, the stakes are even higher, but the core concept remains the same. Robotic drones can use similar technologies, like LiDAR and infrared sensors, to locate stranded astronauts or damaged spacecraft in the vast emptiness of space. The challenge lies in adapting these tools to work in zero-gravity and extreme environments, but the underlying principles of precision and adaptability are directly transferable. Disaster response offers another rich source of inspiration. When earthquakes or hurricanes strike, emergency teams must act quickly to stabilize the situation, often deploying specialized equipment and trained personnel to assess damage and provide aid. In space, robotic drones can take on a similar role, acting as first responders in emergencies. Imagine a spacecraft suffering a hull breach. A robotic drone could swiftly assess the damage, seal the breach, and stabilize the environment, much like a disaster response team securing a collapsed building. The key difference is that in space, these tasks must be performed autonomously, with the drone's AI making split-second decisions based on real-time data. Emergency medicine also provides a wealth of insights. On Earth, paramedics and doctors use triage systems to prioritize care, ensuring that the most critical patients receive attention first. In space, where resources are limited and time is of the essence, similar prioritization is crucial. A drone's AI could analyze the condition of a stranded astronaut, determining whether to deliver oxygen, administer first aid, or evacuate them to safety. By drawing on the protocols used in terrestrial medicine, we can create systems that are not only efficient but also compassionate, ensuring that every action taken maximizes the chances of survival. Of course, adapting these techniques for space isn't without its challenges. The harsh conditions of the cosmos, extreme temperatures, radiation, and microgravity, require innovative solutions. But the beauty of this approach lies in its flexibility. By building on proven methods from Earth, we can accelerate the development of space rescue technology, leveraging decades of experience to create systems that are both effective and reliable. Perhaps the most valuable lesson from Earth is the importance of preparation. Terrestrial rescue teams train rigorously, simulating every possible scenario to ensure they're ready for the unexpected. In space, where the margin for error is razor thin, this mindset is even more critical. By applying the same rigorous training and simulation techniques used on Earth, we can prepare robotic drones to handle the unpredictable challenges of space emergencies, turning potential disasters into manageable crises. As we look to the stars, it's clear that the lessons learned on Earth have a vital role to play in shaping the future of space rescue. By bridging the gap between terrestrial and extraterrestrial emergencies, we're not just improving the capabilities of robotic drones, we're ensuring that humanity's journey into the cosmos is safer, smarter, and more resilient. After all, whether we're on Earth or in space, the goal remains the same: to save lives, solve problems, and push the boundaries of what's possible. As we stand on the brink of a new era in space exploration, the role of robotic space rescue drones and artificial intelligence is poised to become more critical than ever. These systems are not just tools, they are the guardians of humanity's journey into the cosmos, ensuring that every mission, whether to the Moon, Mars, or beyond, can proceed with confidence and safety. Their advanced technology, from autonomous navigation to real-time decision-making, is reshaping how we think about emergencies in space, transforming potential disasters into manageable challenges. The potential applications of these drones are as vast as the universe itself, from repairing spacecraft and rescuing astronauts to deflecting asteroids and exploring uncharted worlds. They are redefining the boundaries of what's possible. But their impact goes beyond functionality. These systems represent a fusion of human ingenuity and technological prowess, a testament to our ability to innovate in the face of the unknown. They remind us that space exploration isn't just about reaching new frontiers, it's about doing so responsibly, with the tools and systems in place to protect those who dare to venture into the void. This journey hasn't been without its challenges. Developing technology capable of withstanding the harsh realities of space, from extreme temperatures to radiation and microgravity, has required relentless innovation and collaboration. Yet with each breakthrough, we move closer to a future where space emergencies are met not with fear, but with capability and precision. It's a future where astronauts can focus on exploration, knowing that if something goes wrong, they have a lifeline in the form of these remarkable machines. The story of robotic space rescue drones is also a story of collaboration. From international partnerships to interdisciplinary research, their development has brought together the best minds from around the world, united by a shared vision of safer, more ambitious space exploration. This spirit of cooperation reminds us that the challenges of space are too great for any one nation or organization to tackle alone. By working together, we can build systems that are not only effective but also inclusive, ensuring that the benefits of space exploration are shared by all. As we look ahead, the possibilities are endless. These drones are more than just a response to emergencies. They are enablers of progress, paving the way for missions that push the boundaries of human knowledge and capability. They are proof that even in the face of the cosmos' most daunting challenges, we have the creativity and determination to rise to the occasion. Thank you for joining us on this exploration of robotic space rescue drones and AI in extreme celestial emergencies. If you've enjoyed this journey into the future of space technology, don't forget to subscribe for more insights into the innovations shaping our world. And we'd love to hear your thoughts. What excites you most about the future of space exploration? Let us know in the comments below. Together, we can continue to explore, innovate, and protect those who venture into the unknown, ensuring that humanity's journey into the stars is as safe as it is extraordinary.